Partial fraction decomposition. This is a pretty scary sounding name, but I'll try to explain it. If you remember adding fractions, something like 1/3 plus 1/2, you would give them a common denominator, and then you would add them together. And then you would have a single fraction as your answer. So you took what started out as two fractions, a 1/3 plus a 1/2, and you changed it into one fraction of 5/6. The idea of partial fraction decomposition is you're working backwards. You're given one fraction and you're going to split it into two fractions. So this is a simplified version with just numbers, or we're going to do it with variables. So when we are done with our partial fraction decomposition, we should end up with two fractions that have something, I'm just making these numbers up right now, something like that. That's going to be our answer. So I'll show you how to do it. Step one, you want to factor the bottom. So I factored the common x out of the bottom. Now we know we want two fractions out of this. One of the fractions is going to have the x and the other will have the x plus 2 as the bottom. And this makes sense because if you remember earlier, we had the 1/2 plus the 1/3 equals 5/6. Notice how the 2 and 3 are this 6 broken out. So you give the denominators the x and the x plus 2. Just each piece of your factor gets its own fraction. Now we don't know what the top is, so I'm going to call this an A and call this one a B, and we're going to solve for A and B to find out what the tops of those fractions are going to be. Next step, I'm going to get rid of these denominators by multiplying everything by x times x plus 2. So now I'm multiplying all three terms by x plus 2. Now this x cancels with this x plus 2 cancels with this x plus 2. This x cancels with this x, and this x plus 2 cancels with x plus 2. So you see there's several things that cancel out. So there it is rewritten with everything canceled out. So then I distribute the A. For the next step, let's put these two x's next to each other. Next, we can factor an x out of these two. Hopefully you can see that a plus b times x is the same thing as ax plus bx. The only way this statement can be true is if this 8 for the x is the same thing as the a plus b, because they're both the number of x's that we have. Similarly, this 10 needs to be the same thing as 2a. It's the only way this whole statement can be true, is if these boxes are equal to each other. So if we set the two green boxes equal to each other, we have 2a equals 10. And we can solve for a, and we get a equals 5. So then we can set the two red boxes equal to each other. We can plug in 5 for the a, subtract 5 from both sides, and we get b equals 3. So now we solve for a and b. So now if we go back up here to the top to our original fraction that we split up and plug in 5 for the a and 3 for the b, that's the answer to the question. We've now rewritten this single fraction as two fractions being added together, and that's partial fraction decomposition. Hope that makes sense. Comment below on what you'd like me to solve for next. I'll talk to you soon. Bye.